Hi everybody, in this video we're going to talk about the difference in difference research design. So first, why are we watching this video? Why are you watching this video? So the purpose of this channel is to help the audience learn all about hedge funds. And this video will teach you about one of the critical quantitative research methods that is used to develop investment strategies. This is for educational purposes only and is not investment advice. And nothing on this channel is investment advice. By the end of this video, you will have a basic understanding of the difference in difference research design, which will help you first read the finance literature, and then, hopefully, after more videos and more work, develop your own finance research. And also, hopefully, work at a hedge fund in the future. Watch the video until the end to make sure you have a rock solid understanding of this research method. One, so you know it later for your academic and professional career. And two, there will be a multiple choice quiz at the end. Please feel free to post comments with any questions or any topics you would like to see covered, and don't forget to smash the like button. Difference in difference research design. It's a quantitative experimental design that makes use of longitudinal data from treatment and control groups to obtain an appropriate counterfactual to estimate a causal effect if the model's assumptions are met. And so what does this mean? So basically it's taking a treatment group, it's taking a control group from longitudinal data, right? So data in the past, um, and it's then attempting to uh, apply a treatment to the treatment group and nothing to the control group, right? And then have both the treatment group and the control group move together through time and have the control group used as the quote unquote counterfactual, which means basically it's the control to the treatment group. So it's just acting as sort of the opposite of what's happening to the treatment group. Um, The difference in difference is typically used to estimate the effect of a specific intervention or treatment, such as a passage of law, enactment of policy, or large scale implementation, by comparing the changes in outcome over time between a population that has enrolled in a program and a population that's not. So you can imagine if you wanted to know like what was the effect of a law in a specific state, you could compare the state's performance to another state that didn't have a passage of a law. And the state that did have the passage of the law would be the treatment group. State that didn't have the passage of the law would be the control group. And as long as the model's assumptions are met, then you can infer a causal effect. But that's as long as the the model's assumptions are met. Okay, so what are those assumptions? First, the assignment to the control and treatment group is not associated with the outcome variable. So whatever your whatever the outcome variable is, whatever the dependent variable is, that is not associated to how uh, the assignment of the control in the treatment group. Second thing is the treatment group have parallel trends in outcome. And so what does this mean? It means that going back to the state, whatever would have happened in the treatment state would also have happened in the control state. So they were like on the same path, they were moving in the same direction, and really the only thing that changed was this one law. Or the only thing that would affect the outcome is this one law. Um, and Okay, the third assumption is the composition of the treatment and control groups must be stable over time. So this is important. So for example, like the people who are living in the control state need to continue to be living in that state and plan to stay there. The people in the treatment state need to be living there and continue to stay and plan to stay there. Um, and then finally, the treatment only benefits the treatment group and does not impact the control group. So, for example, in the state example we gave, the law would only apply to the people in the treatment state and not in the control state. This, you could imagine that if the states were right next to each other, this could actually be problematic, right? Because let's say if the law was to increase the prices of something in the treatment state, then people could like go over the border to the control state to buy it, right? And so that would violate the assumption number 4, which is that this the treatment only benefits the treatment group and does not impact the control group, right? Because then there's sort of intermingling. And then so what's the regression model? So the regression model is sort of y equals beta naught, so that's the constant, plus beta 1 times time, plus beta 2 times the intervention, plus beta 3 times time times the intervention. So time times the intervention is what's known as the interaction effect. And we previously did a video on interaction effect. That's Erdemer, and you can go reference that video if you want to look at the interaction effect. But then plus beta 4 times the covariates. Covariates are typically the controls plus the error term. So in this case, you can see the treatment group is here, the control group is here, and then um, after this treatment, which is at time 1, you can see this goes up, but the treatment goes up by more. And so this dotted purple line is the expectation of sort of the parallel trends, right? We were expecting that this line would be parallel to this line, but then because of the treatment, we think it's now actually has a higher slope. And so we think this higher slope is due to the intervention and this interaction term of time and intervention together. Okay. So the strengths of this difference in difference research design is it's relatively easy to understand, right? Really, we're just comparing two groups, treatment and control. It can potentially lead to a causal interpretation from observational data, right? We didn't have to run a huge, expensive study. We can just look at two groups that, one was subject to a law or something and the other was not. So it's relatively convenient to have this if the assumptions are met. It can use either individual or group level data, right? You can imagine like one individual, maybe twins, right? One went to private school and the other didn't. And how did, what was the effect of private school on the twin? Or you could do it at group level data, right? How did a state do versus a state with a law versus a state without the law? Comparison groups can start at different levels of the outcome. The reason for this is that this focus on changes, right, rather than levels. Changes are basically the change over time, the change between pre and post, rather than um, just the absolute term. So, for example, it's like what was the change if we go back to this picture? What was the change in the treatment group from after time 1 to before time 1, right? And what was the change in the control from after time 1 to before time 1? Whereas levels would be what was the, just looking at the absolute value of the control group versus the absolute level of the treatment group. And so the fact that you're looking at changes, it helps with the comparison groups. And then you potentially account for changes over time and changes due to other factors, right? Because both the treatment and the group and the control group are moving through time, then anything that affects it would have to affect the treatment group differently than the control group, in order for it to mess up the experiment. And so that does help, right? Because if it's a large study, hopefully things that happen over time will be um, it will affect both groups pretty similarly. Okay, the weaknesses. So it requires a control group and a treatment group. You cannot use it if the assignment is associated with the outcome variable, right? And as we discussed, um, that could be difficult, right? Because you could be assigned to a group, uh, to the treatment group, for example, and that could be related in some way to the dependent variable. You cannot use if the control treatment groups have different trends post treatment. So if you're expecting, for example, that this treatment group is going to look different after time 1 for some reason other than the treatment than the control group, then you can't use this because that doesn't have it violates the parallel trends assumption. So you need to have that after time 1 these have to expect to have a parallel trend and only be different for the fact that there's this treatment at time 1. You cannot use if the composition of the control treatment groups pre-post treatment are not stable. This means that basically these groups have to be, where are they? These groups have to be like control group has to stay within the control group pre and post treatment, and the treatment group has to stay within pre-post treatment. This would obviously be a problem if there was spillover between the groups, or if the groups were going to change for some reason. Okay, illustrative example. Suppose we were teaching a course on hedge funds and parents and students want to know if taking a hedge fund class is worth it for their children. How would you design a study to test this question? What factors would you be concerned about? So in this case, you could imagine a difference in difference research design could be one possible research design to look at, right? So what factors would you be concerned about? Well, if the parents are choosing to put their students in a hedge fund class, you might be concerned about selection bias, right? The parents have like, or maybe they work in finance, and so they themselves are hedge fund managers, and so they're putting their students into a hedge fund class. And well, if they run a hedge fund, maybe their income is quite high, um, and so therefore like they're gonna pass that along to their children. And so then like if their children's income is higher later in life, you don't know if it's because of the hedge fund class or if it's because of um, fact that the parents chose the class. And so that's the selection bias issue. Two, the parallel trends assumption. You need to know that the the students who select into the treatment group, that is the class, are going to be along the same um, going to be the same type of students and come from similar circumstances that the kids who don't take the class. And that again is difficult because it's not randomly assigned. People are choosing to take these classes, and it's a very specific type of person who would pay to take a hedge fund class. Third, lack of stability over time of the treatment and control group. That is, if the students all end up going to the same colleges and or all watch the same YouTube channels, then right there's going to be intermixing between the treatment and control group. And so therefore maybe they'll teach each other, maybe they'll be friends regardless, and so therefore the treatment and control group are not necessarily distinct, and that would be a problem. So what research design would you employ to address these concerns? So first, you'd probably want to randomly assign between the hedge fund class and the control group. You'd want to divide students randomly. That would help a lot. The second thing is, given the random assignment, this would ensure the expected performance of the control group is parallel to the expected performance of the treatment group, right? Both before and after, because um, given it's random, especially random in a large sample, you have a pretty good sense that it's going to be parallel. Um, the one thing then you would be concerned, even after a random assignment, you would be concerned about the stability over time of the treatment and control group. That if the kids end up going to the same colleges, um, so that would be something to consider even with random assignment. How would you choose an outcome variable? Wages over what period of time? Would you want 6 months out, 1 year out? Would you want 15 years out? Would you want until retirement? What model would you use? Beta zero, you would use this, right? You would have this interaction term. Again, if you're unclear about interaction terms, you'll go back and look at Erdimer. And again, this is why we watch videos until the end, right? Because all of the material in these videos is cumulative, and so it's important that any video you want to watch it to the end to make sure you fully understand it, so that you can use that knowledge in the next video. Um, but here in a difference regression, we have time. So this would be like the age of the students. The intervention would be the hedge fund class, and then this would be age interacted with the class, right? In covariates, you can imagine what controls we would use. So we might use like the per capita income of the towns that they come from. We might use uh, their GPA to see how good students they are beforehand. We might use like whether they end up working in finance. Um, we might use whether the parents work in finance to see if that drives their behavior afterwards, after the class, etc. Um, and again, so the class year and then the age and class year, this will help help us understand to what extent the class is driving the income later. And so again, the y variable will likely be annual income. It'll just be a question of annual income when, you know, at what age? 10 years out when the students are 30, or that'll we'll have to figure out. And so here's what a diff and diff would look like, right? And again, you want to look at the parallel trends assumption and inspect it visually to make sure that it looks like they're on the same path. And with the random assignment, the students should be. And so you can see here they appear to be on the same assignment at t time equals 1. That's when the class is given, and then the students who let's say on average the average high school students probably works at McDonald's, and then the treatment group takes the hedge fund class, and then we would look at their income um, post treatment. And then you can see here the difference in wages between group C and T. So this is group C, the control group, and T remains constant from time 0 to time 1. At time 1, group T takes the hedge fund class, group C continues working at McDonald's. The wage difference between group T and C at time 2 widens, right? Now the hedge fund group is making more. Assuming all other attributes, innate ability or randomly assigned, and the difference in the slope of the wage increases of group T and C between time 1 and time 2 can be attributed to the hedge fund class, assuming all 4 assumptions are met. And again, and then pop quiz, what are the 4 assumptions? And we have multiple choice. Assignment of treatment control group unrelated to outcome variable, parallel trends assumption, treatment control group stable over time, and no spillover. That's option 1. Or 2, no control variables, parallel trends assumption, treatment control group stable over time, no spillover between treatment and control. Is it 1 or 2? So the answer is it's 1, right? Because we're allowed to have control variables, but we're not allowed to have these assignment of treatment control related to the outcome variable. So let's just think here: are all of these 4 met? Are all these 4 assumptions met? And the answer is if it's random assignment, we probably have parallel trends. But there's a question of treatment and control groups stable over time, because if the students end up going to college and they all go to the same colleges, if there's intermixing, but you could say, well, there's not intermixing during the course, right? And so the question is, there's no intermixing during the treatment. And so anyway, that's one thing you would think about. What about spillover? Do you think it's possible that some of the treatment group knows the control group, and so these students go home and educate these students, like maybe they're siblings, right? And so that would be another thing we think about, is their spillover effect. Perhaps we post these online videos, and some of the kids in this group then go home and watch these videos, and so they learn more. Anyway, these are the assumptions you really want to laser focus on to make sure that your difference research design is solid. Anyway, that's the video. Thank you guys so much. I'll see you in the next video.